can express it as hf, where h is the Planck constant, f is the frequency. Or we can use this h mu. Some textbook, some author use this as symbol of frequency. See that we write like this, you can say where h is called Planck constant, and you have f is known as frequency. Or we can say this also is standing for frequency. So you can call this one equation 1, the energy that is carried by light waves. Or we can also express that energy, E, can also be expressed as hc all over this. This is the second expression, if this is the first one. Of course, this is also known as photon, where you can say E equals photon, or light energy. Then H is known as Planck constant. We have Planck constant. H is Planck constant. Then C is called speed of light. Speed of light, and of course, this is known as wavelength. That's the energy that is being carried by light waves. I said it when we are talking about wave the other time, that wave is a carrier of energy. Wave is a carrier of energy. It carries energy from the source to the eyes of the observers. It is the energy that the eyes receive that stimulates and causes fission. Without the energy getting to you, the sensation of fission may not be, of course, stimulated. You may not see anything. Something has to carry that light energy. What carries the light energy from the source to your eyes is called light waves. Light energy takes, the path light energy takes is called rays of light. Am I communicating?
Yes, sir.
If I carry something on my head, or even carry it on my hand like this, and I'm taking it to somewhere, I have to trek, I have to walk on something. So I am the carrier, that is, the carrier is light waves. What do I carry? Light energy. How do we calculate the energy carried by me? I've given you two formulas for that. So the path taken is now called ray of light. A rays of light, we all know. Rays of light is this. Ray of light. A rays of light is a vector quantity. A vector quantity has both magnitude and direction. So you always show or indicate rays of light by drawing a single line. The line shows the magnitude. The arrow on it, you can have an arrow like this, or you have arrow at the end. This is a ray of light. A ray of light. So it can be written or represented by this or this. Show the rays of light. Now, it is now a crime, punishable under the law of physics, that if you show a rays of light without arrow, you will lose mark. Anytime you have cause to indicate ray of light, you will have to show the magnitude and direction of the ray. Am I communicating?
Yes.
Now, when you have collection of rays of light, we call it beam of light. Collection of rays of light. Don't forget, we say ray is the path taken by light waves. the path taken by light wave is called rays of light. Collection of rays of light. When you talk about collection, that means it's more than one, even more than two. Before you can say collection of something, you have more than one rays that we call beam of light. Some author will say beam of light, some will say you pluralize it by just saying rays of light. So we have beam of light, we have rays of light. What we call beam is simply a collection of rays of light. I don't think that should be a big deal to anybody. Now, types of rays. If we say type of ray or type of beam, we are still talking physics. So, type is the same. When we say ray, type of rays or type of beam, beam of light. So, we are saying that we can say beam or rays of light. So this the collection is beam or rays of light are collection of rays of light. Collection of rays of light are called beam of light. So we now have types of rays, type of rays or beam of light. We have three. By their nature, we have parallel rays or beam or beam. We have the next one, we have convergence rays or beam, and the third one we have divergence rays or beam of light. These are three types. You don't need any technical something when you say something is parallel. The parallel rays are rays that can never meet. Parallel rays are rays that can never meet. When you say something is parallel, they have two parallel lines can never meet. The angle between them is zero. So when we say parallel rays or beam of light, we are going to draw some of the lines that can never meet. You can draw as many as possible. Beam or ray, we put direction on it. This could be A1, this could be B, C, D. To have it as vector, and vector. So these are parallel beams or rays of light. Prolong it to the front or back, they can never meet. You prolong the parallel ray to the back and front, they can never meet. Then we talk about convergence. Convergence rays or beam are collection of rays that can come together at a point. Collection of rays that can come together at a point are called convergence rays or beams of light. It means when you prolong them, they will meet at a point. So such rays are called convergence rays or beams. So they converge. They tend to converge. A ray that tends to converge can meet at a point when they are prolonged. Have like that, can have like this, can have like this. So it means when you prolong this, at a particular point, they meet. This is what we call convergent rays or beam of light. Of course, when you prolong, they will meet at a point somewhere here. These are called convergence beam. You can just put it as a simple form. Rays that can meet at a point are called convergence rays of light or beam. Then we also have divergence. The ray that appear to have come from a point, they spread out from a point. They are called divergence rays. All rays that you will come across in this ray diagram is either the rays are parallel or they are convergent or they are divergent. There is no other ray you can meet. If you take a ray from an object, it's either the ray is diverged, it's either the ray is converged or parallel. There is no other ray you can take from any object under light ray that go beyond this. So that's the type of ray. Now we quickly talk about properties of rays or effects of ray. How does the ray move? And that leads us to rectilinear propagation of waves, the light waves. Rectilinear. The word rectilinear, anything linear has to do with straight line. Rectilinear propagation of waves. Rectilinear propagation of waves. What does it mean? When we say rectilinear, it's just an English word. It's just a phenomenon we use to describe the straight line traveling of light waves. That the light ray can only go on. That's the way light wave behave. It goes on a straight line. Light ray cannot bend. A rays of light goes on a straight line. That's what we refer to as rectilinear propagation of light. Rectilinear propagation of light is a phenomenon used to describe the straight line traveling of light ray from the source. That simply means the light can only go on a straight line. We have two simple experiments you can use to demonstrate that light can only travel on a straight line. The rays can go on a straight line. If you say light travel on a straight line, it means the path it takes. It means the path it takes will always be straight, because the light can only go on a straight line. So it means the rays of light can always be a straight line. It may be parallel, it may be diverged, it may be converged, but must be a straight line. Am I communicating?
Yes, sir.
Now we have the effect of the. What are the simple demonstrations? You can do that at home. It's so simple. It's not technical. You can just take a cardboard, even your note. Fold the cardboard or your note to make a pie. You can buy cardboard, fold it to make a straight pie. At the end, one of the ends, put a candle there. Lit the candle. Set your eyes to the other ends. You will see the ray. You will see the light. The light you put at the other ends. Then you set your eyes on the other end. As you put the candle at one end, set your eyes at the other end. You'll be able to see the light at the other end. You'll be able to see the light you put the first end. Then you now take another cardboard. Make the cardboard bend to make a U shape with leg. So if you, now what I mean is, you will make a cardboard straight like this. You have a fold it like this. You fold. No matter how long the cardboard is, you can put a candle here, small candle, and lift it. So you set your eyes here. The rays of light from here, at least this side, we're able to see these rays of light. We go through this and fall into the eyes of the observer, because light travels on a straight line. Now you have this like this. You form another pipe to make, bend it like this to make this. Form another pipe. Let the pipe make this U shape. Then you put a candle here, just as you did before. Now set your eyes here. You don't need anybody to tell you that a rays of light that penetrate here will be blocked by this. So this eye here sees no, this is rays of light here. The rays of light is blocked by this bent part of the eye. So these rays of light will not stay because there is space above. It bends up and come here to see. This eye will not even see this one because the rays of light will not reach the eyes of here. Why? Because light only travels on a straight line. Does not require any technicality before you know that. Then another simple demonstration you can do is to cut the cardboard into 6 pieces of equal dimension. 6 pieces of equal dimension, equal size I mean by dimension. Then arrange the first 3. Let the first 3 drill the hole at the center. You drill a hole at the center like this. And you can label the first 3 A, B, C. Arrange them to be on a straight line. All this cardboard, let them be on a straight line. So you now put a candle here. The candle is having here. Obviously, the rays of light will pass here, get out here, pass here, get out here, then go to the eyes of the observer because you arrange them on a straight line. All because light travels on a straight line. So this eye here will be able to see the rays of light from this candle. This is the source. You have this as source of light. The observer sees at the other end. That is to prove that light travels on a straight line. Now rearrange this cardboard. Arrange another one. But this time around, make sure the 3 cardboard are not forming a straight line. You drill at their center. Another one is somewhere here. Then you have this here. So it's just like this. Now you have a hole here. You have a hole here. You have a hole here. As the rays of light from the candle enter here, it gets out here and it will be blocked. The eyes of the observer here sees no rays of light because the hole here is not straight with it. It's not straight with it. So the rays of light will be blocked by this. If the 2 simple demonstration shows that light can only travel on a straight line, and that is what we call rectilinear propagation of light. Very simple. Light will not bend, it goes on a straight line. And the phenomenon used to describe that is called rectilinear propagation of light. It's as simple as that. Now, effects of rectilinear propagation of light. Effects of rectilinear propagation of light. What are the effects of rectilinear propagation of light? 1, you have shadow. Shadow is an effect of rectilinear propagation of light. Then 2, you have eclipse of sun. You have eclipse of sun. Then you have eclipse of moon. Then you have pinhole camera. All these are effects of rectilinear propagation of light. Shadow. We all know what the shadow is. Can somebody explain or define shadow in the class? What do you understand by shadow? Is it properly defined? Yes. Is it part? Okay. When we say shadow, Both of them make definition of shadow in pathway. What brings about shadow is an opaque material. Maybe before we define shadow, let me quickly say this, then you understand it better. Optically, materials are classified into 3 categories or 3 types. So under light, materials, we can say, okay, under this, we have classes of material under light waves. We have classes of material in optics or light waves. We have types of material or classes of material in optics. There are 3 of them, 3 classes. 1, opaque materials. There are 3 classes of material in optics. They are 1, you have opaque material. 2, we have translucent material. And number 3, you have transparent material. Translucent material and transparent material. We have translucent material and we have transparent material. The light cannot pass through us, so our body absorbs it. You can give example of opaque material as, of course, human body, clay, wood, and so on. They are opaque material. Metal too. Anything that will not allow rays of light to pass through it, such material is called opaque material. So then we said translucent. Translucent material is between opaque and transparent. They allow light to pass through but scatter them. The light passes through and at the end they get scattered. That's a translucent material. You can take up the translucent material like this and faintly you see the other side. Some of the cloth you wear are translucent. Faintly we see the other ends of the cloth. So they are called translucent. Everything you put under will be seen. The color of what you put under will be seen. Such materials are called translucent material. When you place that material on the diagram, you can trace the shape of diagram out. Do you understand what translucent materials are now? Yes, if you have kerosene, just drop kerosene on the paper. When you drop kerosene on the sheet of paper, you leave the sheet of paper up, the sheet of paper will be translucent already. Or sometimes oil, when you buy your pop-off or buns or whatever, the paper you used to buy, the oil will be there, you see something will look like translucent material. We have some louvers or glass. In those days, those blades they used to put, okay, like this, you can see they already broken everything. The louvers that were there before, the first 4 below used to be translucent louvers, whereas transparent may be put above. If you put transparent, somebody outside move closer to the window will see inside. But with translucent louvers, even without cutting, you cannot easily see what is inside. How many of you have seen translucent louvers before? Good, good. Translucent material, ray passes through it, but scattered. It passed through it and scattered. Aside the glass I mentioned, I have given you some other material that are. Some of this paper you buy, A4 paper or whatever. If you go to where they are selling paper, you have some of the paper that's the gauge, the thickness of it is so tiny that when you leave the paper up like this, you see the other side. Or you place it on your book like this, the diagrams or the letter on that book will now be seen faintly. Have you seen what I'm trying to describe to you before? Such materials are called translucent material. Like if you want to construct Kino camera, it is translucent paper we use to cover opposite side of a Pino camera. Translucent material cover the opposite side of the pin hole in a Pino camera. So that paper we can see through it faintly. That's what we call translucent material. I don't need to stress myself in transparent. Yes, everybody knows you don't need to be in science before you know what to call transparent material. It's just a material that allows rays of light to pass through it without scattering it. Light passes through it, and we all know the best material that we call transparent. Of course, some of the cloth, when your cloth, they see what is under, people will call it transparent. It's not really transparent, that one is translucent. When we say transparent, it has to be the one that allows rays of light to pass without any scattering. Go through it. You can clearly see the other side of it. Take for instance a clean glass. That's what they use to cover the headlamp of a car or your torchlight. They cover it with a glass which is transparent. So if you hold it up like this, you see clearly the other side. Such material is called transparent material. Do you understand? Yes, whichever the case, the three different categories. If you are not opaque, you may be translucent. If you are not translucent, then you are transparent. So if what you put on under cannot be seen outside, then you are opaque material. So if you stand in front of any light, your body blocks the light. Then, or if you put your cloth in front of a light and the light does not pass through that cloth, you should know that that cloth is opaque materials. So there is no material that cannot find itself under one of the three classes mentioned. Back to shadow. So before you can form a shadow, we need three components. We need three components to form a shadow source. That's light source. We need opaque material and we need screen. The three of them, this is opaque material. Collinear, that means appear to be on a straight line with the source. We can have a source of light here. This is the source of light. And of course, you can have a screen. A screen is a white, a flat surface. A flat surface on which the shadow is formed. Now, you can pick the diagram up from your textbook very well, but let me just use this to explain. Now, if I want to draw it properly, I must get a ruler. I have told you that the rays of light must be straight, and you must always put the direction on it. So if you want to sketch your own, what you sketch now may not be proper. You have to use ruler to draw. You can pick the diagram from your textbook. You have good diagram in Principle of Physics, and you have it what you have in New School Visits 2 is also correct. But now we have this one as source, then we have this as opaque material, and of course this is our screen. A screen is a flat surface, usually white, of course, can be any color. It has to be flat, on which the shadow is formed. The shadow is formed on that screen, and the shadow is due to inability of the rays of light from the source to reach that portion on the screen. So the portion the light cannot reach will now be declared as shadow. Shadow of what? Shadow of the object that blocks the rays of light. I mean, shadow of object that causes inability, that makes the rays of light not to be able to reach that side. Now, how do we sketch this? You need rays from the source. So many rays come from the source. But for simple diagram, you may pick 2, or pick as many as you want to pick. But with the 2, you can sketch the shadow. So now you pick the rays like this, the one that passes through extreme end of the opaque, like this. So all other rays within that range are blocked. All other rays here are blocked. These are ray. All these rays are blocked. They are not allowed to pass through these. It's only these 2 that pass above the opaque material will now form. So all these parts will now be dark. From the range now, from this to this range, they form shadow. This is what we call shadow. The process of achieving this is this must be on a straight line, and the total darkness will now be found here. And that is exactly what we refer to as shadow. It's simple. This is what blocks these rays, that make the ray to be unable to reach this portion. The part the ray cannot reach now is called shadow. The shadow of this object is obtained on the screen. As well, you can always see my hands is forming shadow. When I put it like this, I can see the shadow of my hand. If the rays of light is coming, my hand blocks it, and the shape of my hands will now be formed on the screen as a shadow. If you are walking under the sun, you see your shadow on the floor. It is because your body blocks the rays of light that would have reached the portion where your shadows is. The inability of those rays to reach that portion form the shadow you are looking at. It's a simple thing. Something blocks the ray, and when the ray cannot reach their place, that place will be dark, and that is what we. Now, the shadow, the size of the shadow depends on 2 things. The size of the shadow depends on the size of the opaque material, how big opaque material is, compared to the size of the source, compared with the size of the light that produce the rays. If the opaque material is small compared to that of the bulb, that is, if you increase size of the bulb is bigger now than this, then you have opaque material here. What we will notice is that the rays of light you have here, we have part of this shadow will be total darkness, some part will be above. So you have a kind of things like this and like this. So if properly drawn with the ruler, so this part will be in total darkness. This part will be total. Above this will be partially dark. So above this, from here to here, it's about this one below is going to be in complete darkness. But above, little rays of light reaches that place. Then above where the little rays of light reaches, large rays of light reaches the place. So where we have total darkness here, we call that umbra. Then where we have little rays of light reaching, penumbra. And you put arrow like this, arrow like this, arrow like this. With the aid of ruler, you can indicate that. So the bigger the source, this is when the source is big, then we can have umbra, penumbra. But if the source of light is small, compared to the size of the opaque material, total umbra will be seen. There will be penumbra. So it means you only have shadow, no umbra, no penumbra. The diagram can be seen clearly in the textbooks you are having. And let me also advise you, you don't teach this diagram, but you can practice it. When after you have read all what you want to read in the day, take your pencil, try to recollect the diagram, learn the diagrams you want to learn, and you can draw it. When you are drawing, the sleep will go. When you are drawing, the sleep will go. That's why I said you must have read all what you want to read. By the time you are dozing, you are about to sleep, take paper and pencil and try to recollect the diagram you have practiced, or try to practice diagram. Open the textbook, the color diagram you have in the textbook. Try to practice drawing in it. And each night, when you are done with your reading, you are about to sleep, you always practice the diagram. With the aid of diagram, explain shadow. That's the common question you have under this aspect. Most of the questions they will ask you here will be explained with the aid of diagram. And let me also warn you, I have told you when we are discussing WAEC the other time, when the questions like explain with the aid of diagram is asked, please listen to me. When the question like explain with the aid of diagram is asked, do not draw the diagram you are not sure. It's an appeal to you. Don't draw the diagram if you are not sure. Go on with your explanation. It's better to lose the mark for diagram than to lose the total marks. If the question says with the aid of diagram, explain this, and you just draw something, it's indirectly you are telling the examiner that don't waste your time. Once the diagram observe that you have drawn not workable, the diagram that is not workable is drawn, it will not waste its time to read your explanation, because what we believe is that you are explaining your diagram. The diagram is wrong already. All explanation you are making under it, you are explaining wrong diagram. Why do we need to waste our time in marking that? That's the rule of WAEC. If they say we need a diagram, explain it, and your diagram is wrong, technically what they do is they start scoring you from the diagram drawn. It will be better to leave the space of diagram, go on with your explanation. Then it will be taken that, oh, time does not permit you to come and show the diagram. Probably you want to explain before you show the diagram, and time does not permit. So he or she will take his or her time to go through your explanation and score you accordingly. Because you have not made a committal statement. We call it committal statement. When you already showed the wrong diagram, you already committed yourself. The difference, you are different, the two cases are not the same. Somebody did not draw and explain below. The explanation may be right. You get mark for that explanation. You didn't show diagram at all, you score 0 for diagram. Somebody draw something which is not workable. will score 0 for what he drew. Probably the explanation is correct. He has explained very well. But the fact that he drew wrong diagram, nobody is going to read through the explanation before you are scored accordingly. Please and please, there may not be, of course, we are running off this week. You may not be around when the exam is near. All this technicality, you have to take note of it. There are questions like that with no explanation, but you may not be able to draw the diagram. Please don't just draw anything. Go on with your explanation, leave the space for diagram alone. But the way you can practice, I've just told you. Every night, you still have more than 10 nights before you write WAEC now. If you try to learn the diagram each night, you can learn as many as possible diagrams every night. Subject you can do in the night, after you have read and you are dozing, you want to sleep and you don't want to sleep, you can draw, learn diagram, you can calculate. So when you are doing, you can work physics, you can work mathematics. Before you know, you will get to the mid of the night, the sleep will have gone. When you are actually working, every part of your body will be involved. But somebody that is dozing cannot take biology and start reading. When you are tired, you have read. You can read up to half a page before the book is thrown somewhere else. Please put all these things to practice. So that is that. Now, with the aid of diagram, explain shadow. We've done that. Yes. And we have what we call penumbra. We have what we call umbra. If your diagram is correctly drawn, you have little explanation to give. You just make reference to workable diagram you drew. And you can only have workable diagram if you have practiced drawing the diagram very well. Is that taken? Yes, sir. So that is that. The second one, that's what we call eclipse of sun. What do you understand by eclipse of sun? Or what is other name for eclipse of sun? All these things you have done, there are no calculation here. The technicality thing here is diagram. Yes.
Solar is also for solar eclipse.
Solar eclipse, yes.
When the sun gets and the moon are in a straight line, so that the moon comes in between the earth and the sun.
That's better. We are having three, just like shadow. See, you can compare them. I said there are three major components in shadow. In eclipse of sun too, you have three. There must be source, there must be opaque, there must be screen. Eclipse of sun, we have three heavenly objects that are collinear. Collinear. They don't come together like you say, because when something come together, it's an English word. You say when when earth, moon, and sun come together. When something come together, my hands are together now. You already convert together here. No. But when they form a straight line, like he said, when they arrange themselves on a straight line, they are collinear. The earth, the moon, and the sun are collinear. Then every other thing is like shadow too. Sun is the source. What does sun do? Sun releases light waves. Light energy. And that energy is being carried by light wave. And the path the light wave takes is called rays of light. So the sun releases energy, which is carried by the light wave. And the path from the source, from the sun, the path the light wave takes is called rays. So rays of light come from the sun. It comes from the sun to the moon. And being a small opaque material, moon is an opaque material. It does not generate rays of light. So part of the ray will be absorbed by the moon, and the ray above the moon will reach the earth. So moon is smaller than the earth and the sun. Moon, which is also collinear, this is the sun. You have your moon, and you have your heart like this. They are all collinear. With the aid of your ruler, you can always put the ruler, trace a rays of light like this, just like shadow, and you drew another one that will pass above it, like that, and you have another one with the aid of the ruler. So you have it like this. You can have direction. This is the sun, and this is moon, and this is the earth. So this part where these two is will be in total darkness. This is where we have your umbra. Complete darkness will be here. Above that complete darkness here, above this complete darkness here, you have some part of the heart. You can call this one A, part B, part C. So where we have B and C, we have little rays of light reaching those parts. And that part will now be called penumbra. So some part of the heart, above that penumbra, rays of light gets to other part of the heart. The brightness of the light gets to that place. So if you understand shadow very well, eclipse of the sun will be clear to you. Cleared?
Yes, sir.
Good. The same thing with eclipse of the moon. Is the arrangement that will change now. That means the heart comes between the sun and the moon. And the heart is bigger than the moon. So at a particular point in time, the moon will now be completely dark. It depends on the position. Rotation is taking place. So if the moon finds itself at the other side of the heart, then you have complete part of the moon will be in darkness because it's smaller than this. All these things are technical, but no calculation, no simple calculation there. It's just like reading your biology, whatever. The technicality there is the diagram, and you can use line. You cannot use freehand drawing like this. It will even surprise your mind because the rule is that light travels on a straight line, and you have to use line ruler to draw whatever you want to draw. So eclipse of sun. The only area where calculation is that I want to, if time permit, then if not, I will start from there on Wednesday, is the Pinot camera. So under Pinot camera, we have little calculation, and I will advise you, because time is gone now, I will advise you to read about all these before Wednesday. I want to move as far as possible to briefly talk about reflection of light and refraction of light. I don't know, we can repeat it on Saturday if time permits us. We want to see reflection of light on concave mirror. Then reflection of light on convex lens. If you can demonstrate all that, you can read your book and come to the class on Wednesday with any question you may have. So you read about reflection, read about refraction of light, and practice the ray diagram of that's when you put an object in front of concave mirror at various positions. You should be able to sketch the image formed by there. Is that taken?
Yes.